Okay, let's look at a device that we've used an awful lot but never really explained how it works. So we're going to look at a cathode ray oscilloscope, and it is based upon really the principles that we've studied in this booklet. So we start off with a tiny little power source connected to a filament, essentially, and that causes a filament to heat up, and we get thermionic emission where the electrons then have enough energy to escape the atoms, and if that was all that happened, they'd just float around there. But what we then do is we connect up a much larger voltage, so say something like maybe 4,000 volts across here, and connect this to a metal plate of some sort. So here's our big metal plate. But what we do is we have a little hole that goes through the center of that, and beforehand we might have said that, okay, this will make this plate positively charged because it's connected to the positive side of our power supply. This will be negatively charged because it's connected to the negative. But really what we're saying is there's an electric field that exists in there, and it's going to accelerate our electrons. And if we leave enough of a gap, they will gain enough kinetic energy and then pass through that gap. And we just use this, we came across at the start of this book, it's called an electron gun, to produce a beam of electrons. But what happens at beam next is if we put another metal plate here and another metal plate here, we can connect that up to some external voltage. Okay, so say we have a little voltage here and a voltage across here. And it just means that this plate becomes positively charged and this plate becomes negatively charged, which will produce an electric field in between those two plates. Now what that's going to do to our electrons is it's going to accelerate them downwards. So they're going to be deflected towards the bottom plate. The size of the voltage we put across these two plates in red will govern how much those electrons get deflected, which means then if we can measure that deflection, it's actually an indication of the voltage that we put across those two plates. So we can use this method to measure voltage. The last thing we do then is we put a fluorescent screen at the end of our cathode ray oscilloscope, and when the electrons hit into the screen, they knock into the atoms. They transfer their kinetic energy to the other electrons in the atoms. The electrons move up an energy level that we did in quantum theory last year, move back down, and when they move back down, those electrons then emit a little photon of light. So essentially, all we're saying is the electron beam's invisible, but when it hits into this fluorescent screen, it produces a little bit of light wherever they hit. So if someone was looking at the screen from over here, they would see a little bit of light on the screen in that position. Now, can't really draw this overly in 3D, but we actually have two sets of plates. We have one along the x-axis, and then we might actually have a metal plate above, and also a metal plate below those electrons. And we can put another voltage then across these two plates. And if this top plate was positive and the bottom plate was negative, the electrons would not only be deflected this way due to our plate here, they would also be deflected kind of towards you as you're looking at it like this, because of the positive plate here. So we can deflect our electrons using our two sets of plates either in the x direction or the y direction. Okay, so that's our little schematic. Here's how it looks in the diagram in your books, much nicer. But you can see in this region here, labeled number 2, that's our little electron gun. So you can see the electrons get created here and they're accelerated out of that. They then spread out. So in fact, we have an extra bit we didn't go into here, which is this little magnetic coil that just focuses the electrons. We don't need to worry too much about that. The beam then passes between the plates, and you can see that there's a plate here and a plate over at the other side. They're going to deflect the beam as we're looking at it kind of left or right. So we can put a voltage across them, and then we can put a separate voltage across this to deflect the beam vertically. And then you can see the beam goes on, hits our little screen, and where it hits our screen, it'll produce a little dot of light.